Everyone, welcome to our final session, finally, of the difference of of the quadratics course. Um, 25 videos. This is the 25th video. And I hope you all stuck out straight to the end with it. Right? So we'll talk about the videos themselves afterwards. So the difference of two squares is actually a topic that was supposed to be done in the earlies, but we didn't need to do it because this was a course focusing more around the quadratic graph itself and not really to do with a lot of the other parts of factorization of algebra. However, the difference of two squares is just something attached um onto this, right? So the first thing I want to talk to you all about is something that we call conjugates, right? Conjugate of terms, right? So we want to talk about the conjugate of a term, right? The conjugate of a term. So, what is the conjugate of a term? It's a funny sounding word, but let's say that we have a term, usually a binomial, which is a two-part term like x plus 5, a minus 3, 4 minus b, 7 plus w, right? And the conjugate of that term is literally the same constituents, x and 5, but a different operation between them, right? So let's put this as minus 4 plus b, sorry, minus 4 plus b. Yeah, so the operation between a and 3 is subtract. So the operation here will become plus 3. That's the conjugate of a minus 3. The conjugate of negative 4 plus b is the same negative 4 and p, but the operation between them is minus. And similarly, the conjugate of 7 plus w is 7 minus w. Now, what does this have to do with this topic called difference of two squares? Now, let's look at the products of these terms. X plus 5 into x minus 5. Now, you all know how to expand this out, right? So I'm not going to go through the long process of doing it. You all know how to do this by now. If not, drop back and you will learn how to expand the product of a binomial. Go back to about 15 or 16 videos ago. What you will end up with here is I'll do this the long way. X by x is x squared. X by minus 5 is minus 5x. 5 by x is plus 5x. And 5 by minus 5 is minus 25. But this is like minus a plus e. So this will cancel off with this. This leaves us with x squared minus 25. So when we multiply something by its conjugate, we end up with something special. Now check how cool this is here, right? I could rewrite 25 as x squared minus 5 squared. So I have the same, so I have the first term squared and the second term squared, and I am subtracting them. Yeah. So when I have a term multiplied by its conjugate, right, what we'll always end up with is a minus 3 into a plus 3. The first term squared, which is a squared, minus the second term squared, 3 squared. And this will just give us a squared minus 9. Similarly here, this is minus 4 plus p into minus 4 minus p. You will get the first term squared, which is minus 4 squared minus p squared, which will give us 16 minus p squared. And lastly, and you can do these the long way to see if it's true, and you will get it. 7 plus w into 7 minus w will give us 7 squared minus w squared, which will give us 49 minus w squared. So therefore, what is the difference of two squares? When you could identify that something is of the form of the first term squared minus the second term squared, you could always factorize it into this. Whatever is the first term minus whatever is the second term into whatever is the first term plus whatever is the second term. Because if we could go this way, we could also go back this way here. So we could go from 49 minus w squared back to this form here. So let's say, for example, I want you to factorize. Now, the expansion, not hard, but let's factorize these terms coming up here. And you'll see that once you have this formula, you are very, very good with that. Factorize 1. Let's go with 36 minus x squared. So what we need to do, we need to show that both of these terms are perfect square terms. So 36 is 6 squared minus x squared is some term x being squared. But then this is of this form here, some first term squared minus some second term squared. So what this could break up to is the first minus the second, which is 6 minus x into 6 plus x. Done. That's it. You can put 6 plus x first, then 6 minus x. It really don't matter. All right, let's go again. Let's go with 25 minus 49m squared. Now this one is a little bit more challenging. 25, as we know, is 5 squared. Now 49m squared is the same as 7m all squared. Yeah? 7 squared is 49, m squared is m squared. So now, and this is the first term squared minus the second term squared. I could break that up into the first term minus the second term. So 5 minus 7m into 5 plus 7m. That's how easy this is here. Number 3. Now this one is one that has always kept some people. Let's go with 100 w squared minus 1. Now 100 w squared looks good, right? We know the square root of 100 is 10 w all squared. 10w by 10w is 100w squared. Now 1, always remember that 1 is the same as 1 squared. This is again in this form here. Some first term squared minus some second term being squared. So we could break this up into 10w minus 1 into 10w plus 1. Right, that's how easy this is. It doesn't really have to be hard. Right, I'll just do a couple more examples with you all. Let's go with 4p squared minus 64m squared. No, actually we use m already. Let's go with x squared, y squared, right? Y squared, right? So first things first, look this 4 and this 64. I could first factorize out this 4. So this becomes 4 into p squared minus 16y squared. So if you could factor a constant out of them, factor it out first, and then try the difference of two squares. So 4 into, this is p to b squared minus 16 is 4 squared and y squared. Yeah, because then 4y by 4y is 16y all squared. So this will give me 4 into, this can now factorize into first term minus the second term into the first term plus the second term. So this one, just in case you could factor out a number out of the two terms, factor it out first and then proceed to break up into perfect squares. All right, let's do one more again. Let's go with 81 c squared minus 121 t squared. All right, so 81, and I into this, we know 81 is 9, right? 9 squared. So this is 9c all squared. 9c by 9c is 9c squared. 81c squared, sorry, minus 121 is 11. The square root of 120 is 11 and t all squared. So again, this looks like first term squared minus the second term squared. The first term is 9c, the second term is 11t, sorry. So this just becomes the first minus the second and the first plus the second. So it's 9c minus 11t into 9c plus 11t. Now, I wouldn't say that this has far-reaching applications, right? Let me show you a quick method in the multiple choice that they usually give you. They will tell you in the multiple choice, evaluate this here. Find the square root of 17 squared minus 15 squared. Right now, how do we do this? Right? Actually, they might even ask you for the square root. Let us say they'll ask you to evaluate this. Now you might go on the side and you might know 17 squared and 15 squared offhand, and this is a difference of two squares, and this is 17 squared minus 15 squared. So what does this become? It becomes 17 minus 15, the first minus the second, into the first plus the second. 17 minus 15 is 2 into 17 plus 15 is 32. Actually, yeah, they could ask you for the square root. Right, so the square root of all of this is 2 by 32, which will be the square root of 64, which will give me 8 as the answer here. Yeah. So sometimes they may ask you for this here. I think that this one itself came in the past papers in the multiple choice. So this is a little side note as to where it came from. And this here is the difference of two squares. And notice difference of two squares is not the same as the perfect square. So with this being done now, I am officially to the end of the CSEC Mathematics Quadratic course. Right? It's been a long couple days for me doing these recordings, right? But I really did it to help out at least any few people in the Caribbean and anywhere else who could probably use this assistance in quadratics. As I said, at the end of the videos or in the link or in the comment section, somewhere over there, you all will see one entire worksheet. And this worksheet, you just look for it and look for the session number, right, in that worksheet. So you will see session 1, session 2, session 3, straight down to session 25, and questions in each of them. The worksheet will be based on that session, on each session, sorry. So you can always try out those questions. You always have me there in the comment section. I won't check it every week, of course, but as soon as I could, I'll check it, right? But I'm sure there'll be people to help all out in the comment section too. So thank you all for staying for this. It's very serendipitous that it ended off at the 25 video. I wasn't planning for it to end at the 25th video. I honestly thought that it would have been 15 videos, but it ended up taking a little bit longer, but that's fine. So I'm going to upload this 2 ways on YouTube. I'm going to upload each video individually, and I'm going to also upload one long video with all 25 videos in it. Right, so that's if anybody wants to sit down and go through the video in its entirety, they could do it like that as well. So that is it, and I am glad if anybody could have learned something from these videos. And feel free to share it. If they have any teachers out there who are looking at the videos, they can feel free to share it to your students as well. They could use the worksheets. They mightn't be very, very detailed, but they will be a good starting point to evaluate your students. Right, and if you're teaching yourself, you can use it to evaluate yourself as well. So, with that being said, that is it for this CSEC Quadratics Mathematics series. In due time, not right now, not anytime soon, right? I will be posting the CSEC Additional Mathematics. AdMats will use these 25 sessions as well as at least an additional 10 sessions again to do the AdMats Quadratics. Right, so until the next set of videos and in the comment section, I'll see you all. Right, everybody, please stay safe, and I hope you all use these videos to your benefit. So take care, everybody.